He was analyzing and accessing information about the ether of space-time, and he discovered that the entire ether, in other words, everything this soup that we're operating in throughout the entire universe, is running on a specific code. It's called an Adinkra code. It's called error correcting codes. The same exact kind of codes that run search engines and web browsers.
Do you believe that the universe is mathematical?
Oh, absolutely. The language of God is mathematics, because mathematics can literally explain everything that we experience and everything also that exists. Even the fact that we're existing in a light matrix can be proven through mathematics. So we're living in a matrix that's basically written on mathematics called Adinkra codes. And these Adinkra codes go all the way back to the Dogons, the Dogon tribes out of Mali, Africa.
Yeah.
They actually originated these codes, and they were given these codes by the Nomo, and they learned them. They drew them out as art forms. But now, and they put them on clothing and blankets and everything else.
So the Dogon tribe, very interesting tribe, that was able to discover, systems before telescopes and things of that nature.
Yeah.
So how did they arrive to be able to, because I know a lot of people, I posted about this not too long ago, people want to understand how the hell did the Dogon tribe arrive to it, right? I just subscribe to, us being, gods, melanated beings on this planet Earth. We connected in a way that we just don't understand anymore.
Right. Well, to be honest with you, if you go all the way back to the ancient Dogon history, before they got to Mali, they were in the land of Kem. They were the original inhabitants of the land of Kem before it was called Egypt. And so...
Kem meaning the land of blacks?
The land of blacks, correct. Exactly, land of blacks. Kem was black, it's all black. That's in the tablets. So they, according to their records and their handed-down verbal history, their records are etched into caves and stuff like that. The Nomo came here from Sirius B. Okay, so there's a trinary star system that we know of called Sirius, the Sirius star system, A, B, and C.
Yeah.
B is a fail star. In other words, it ran out of fuel, turned into a white dwarf. These beings were orbiting on a planet that orbited that star, according to the Dogon, not me. Came here, they're called the Nomo. The Dogon called them the Nomo. Taught them all about the star system, the orbital pattern, our entire solar system, the names, the shapes, the sizes, the colors of all the planets in our solar system, all the planetary alignments. And they even knew that that white dwarf star was so gravitationally heavy that one spoonful couldn't be lifted by over 1 million men. They even knew that. We learned that in quantum mechanics and quantum physics in the 1970s, 1980s. We hypothesized it. And obviously we couldn't even see that star until the 1980s, 1970s, I'm sorry.
So when did they record it?
Thousands of years ago.
Thousands. Of years ago.
It's like, we're talking about over 6,000, 7,000 years. They even had depictions of them and everything else, and they taught them how to make these Dogon masks, but they also gave them the Adinkra codes. Now these Adinkra codes look like designs on clothing and patterns. When you turn these designs into three-dimensional structures, they become something called error correcting codes. And Professor James S. Gates, a black professor who used to be the science advisor for Obama when he was in office, he's now the professor, I believe, at the University of Maryland in supersymmetry and theoretical physics. He discovered these Adinkra codes. He rediscovered them, obviously, and he turned them into three-dimensional objects. And then from there, he found the error correcting codes. He was analyzing and accessing information about the ether of space-time, and he discovered that the entire ether, in other words, everything this soup that we're operating in throughout the entire universe, is running on a specific code. It's called an Adinkra code. It's called error correcting codes. The same exact kind of codes that run search engines and web browsers. That's what's running the universe.
So listen now. At certain points in time in the interview, the glasses got to come off.
Chuck, I've been public on the fact that I'm waiting for someone to convince me that we don't live in a simulation.
I've heard you say it.
The arguments put forth have been quite convincing to me. And most of the best arguments are traceable to a guy named Nick Bostrom, a philosopher at the University of Oxford.
Okay.
Here's the argument. Ready?
Go ahead.
Our computing power is growing rapidly.
Right.
We create simulations of worlds. We have video games with characters that are inside the video game.
Right.
Imagine a day where you can simulate a world so perfectly with life forms, humans, so well that you can recreate every single neurosynaptic thought you could have but now you're in the simulation on the computer,
So,
including the perception of free will.
well, there you have it. Because then, so now you would have enough computing power to imbue the Sims inside of the program with all of the human traits that we possess now.
Correct. Not only our human traits,
Not
but
on-
the world.
but the world.
The world itself.
Right.
And you don't have to have all the world existing there at all times.
Right.
That might be an unrealistic amount of computing power.
Right.
You just need
Enough of the world that they see around them.
nothing that they see around them.
Right.
So you want to start digging, and
that's so funny.
And haven't put the Earth there. There's a flag that goes up in the programmer, and they say, need more Earth. So they
Right.
put Earth beneath you while you can keep digging.
It's like the Truman Show.
Yeah, well, for example.
Right.
Okay.
Cool.
Or does Minecraft, you can build
Or
stuff?
Minecraft.
Right.
Oh, that is Minecraft.
Right. Okay.
God, that guy's a brilliant genius. Okay.
So and we went to the moon. It's okay. Let's make sure the moon is there.
Right.
Okay.
Maybe that's why we can't travel faster than the speed of light. Because if we could, we'd be able to get to another galaxy
Before they could program it.
that galaxy.
Oh.
So much fun.
So the programmer put in that limit.
Put in the limit
'Cause that's the
Speed of
fastest
light.
they can
That's
get.
we can't program fast enough. So we put in a limiter. The speed of light is a limiter so that you can't get to the next thing before we build it.
All right. So let me finish. That's good.
Go
That's
ahead.
good, Chuck.
All right.
So let me finish this. So now that world evolves and they develop computing power.
Right.
And they say, we want to play video games.
So now we're going to make a world.
So then they make a world and they have sufficient computing power that they invent
Right.
to create a whole universe within their computers.
Okay.
And then
They
do
make
that.
a world.
And then they make a world all the way on down.
Right.
It could be hundreds, thousands, billions, infinite.
All right. So far, this sounds like it still works.
That's fine. So now close your eyes, throw a dart. Which of these universes are you going to land in? The first one that's real or the gazillion that are not?
Well, yeah.
Just statistically. Okay.
Am I drinking when we're playing this darts game? Because
Because then you missed entirely
everything.
So we establish the likelihood that one day we'll have the power to do this.
Right.
And then that factors into these statistics.
Okay.
So there's 1 in a zillion, you're the real universe, and 999 zillion to 1
That's your simulation.
That convinced me. And I don't want to be convinced. I didn't like it. And I was just begging for somebody to give me an argument that was cogent enough to undermine that entire reasoning. And I just came across one.
Uh-oh. Who? Okay.
Okay. It's a good friend of mine, Rich Gott.
All right.
He was a colleague of mine back when I was at Princeton.
All right.
Deep thinker, likes calculating the ends of things.
Nice.
With Bayesian statistics. He's heavily quoted in this book, The Doomsday Calculation. And William Poundstone is a smart guy unto himself. And I am now convinced.
Now you're convinced.
Are you ready?
Okay, go ahead.
What do all these... So here is what convinced me we're not in a simulation.
Okay.
Are you seated?
All right. I'm seated.
Are you... Hold on.
I'm going to hold.
Okay. All right. What do all those simulated universes have in common?
They're simulations.
They have the power to simulate
That's
themselves.
what I'm saying. They're simulations.
No, they have the power to simulate themselves.
Right. Oh, okay. Yes.
That's what they all have in common.
Make a simulation.
They have that power.
Right. Exactly.
To simulate themselves exactly. Do we have that power now?
No, we don't.
No, we don't.
Which means that we can't send it. We can't send ourselves into the future as a simulation
Because we don't have that power yet.
So we can't continue the chain.
Wait, so either we are the real one,
right,
or we're the one in the chain that's still evolving to try to then make a simulation within their own world.
Right.
So the odds of us being a simulation goes from a gazillion to 1. I mean, to the likelihood of a gazillion. All right.
It flips.
It flips. 50-50.
Wow.
And I'm good with that. That changes my life completely.
Yeah.
Okay? And no longer are your kids going to say, Dad, it doesn't matter. We're in a simulation anyway. No, you got an argument. You have a rebuttal.
Exactly.
Now, a quick one.
I have to do my homework.
I go. You ready?
Go ahead.
Maybe these simulators have a side activity where they like reminiscing about days before you could simulate. That would be us.
So now we're Donkey Kong.
Donkey Kong. Or Pong.
We're classic. Yeah. Classic game play.
So maybe we're just entertainment, like a historical exercise.
Right.
That's possible in principle. However, let's look at our own conduct with that regard.
Okay.
All right, think of a movie as a simulation, just for the sake of this conversation, which it kind of is.
Is.
Ask yourself, how many movies have been made in a time before we ever knew how to make movies, relative to movies made in the era where we know how to make movies. You can do the numbers. It's small. Yes,
sure.
the Spartacus, there's the OK Corral.
Three Musketeers.
Those exist.
That type of stuff.
Okay?
Okay.
If we are any measure of the incentives of creating simulations, which all we can do with movies at this point, then they might have some historical, but there's way more interesting things and stories to tell in the era of simulations that exist post-simulation.
Right. Yeah.
So even if there are some period pieces that we might be, still most of these would be universes made after they could simulate themselves.
Right.
If our movie-making habits are any indication of anything.
So the chances are we're not a little offshoot, like a little side project.
We could be, just statistically, it's
Probably
not likely.
not. Right.
Because we're throwing darts.
Right.
And most of the stories they're going to simulate are going to be the ones that are in the era of the time they could simulate themselves.
So that still brings us back to we're probably either the first or we're on our way to being the next.
On our way to being the next. That's
Right.
correct.
One or the other.
That's more likely than any other possibility here.
Wow. So no simulation.
Yeah, I'm good. I think I'm real. I think you're real. I think we're good.
Well, real recognize real. So yes.
Are we just dancing puppets, obeying the laws of some computer out there in the universe? Is everything basically a fake? Well, that theory got a tremendous boost with the Matrix series. Because in the Matrix, what we thought was real was actually a computer simulation put into our brain by aliens. And so reality as we knew it was all wrong. Is that possible? Well, the answer is probably no, but for a very sophisticated reason. Life is quantum mechanical. Life is not based on zeros and ones. Photosynthesis, for example, is a quantum mechanical process. It is the basis of all life on the earth, and we still don't know quite how it works. A flower can do calculations that our most advanced quantum computer cannot. Amazing, truly amazing. So Mother Nature is still smarter than us when it comes to the quantum theory. If you want to simulate the weather, for example, you have to simulate the motion of trillions upon trillions of atoms. No computer is that powerful that it can simulate the motion of trillions and trillions of atoms that just make up the atoms in this room. You can't do it. You're talking about 10 to the, let's say, 25. One with 25 zeros after it, just to model the atoms inside a goldfish bowl. So we're talking about a fabulous amount of information necessary to create a model of a dream. And the most intricate quantum device is you. You are the byproduct of quantum mechanics. If you turned off quantum mechanics, what would happen to your body? It would dissolve. It would dissolve into a bunch of random subatomic particles. And atoms obey the quantum principle. It holds your body together. It allows your atoms to interact with other atoms, to create catalysts, to create DNA and proteins. So you don't really know where they are at any given point. So there's an infinite number of universes that are possible right in your room. And so in other words, it is mathematically not possible to create a fictional universe out of atoms in a fictional way. Sorry about that. The universe is not an illusion. Now, some people ask another question. What if the universe is an almost simulation? That's possible. Maybe you cannot simulate trillions and trillions of atoms because of something called the butterfly effect. Now, what's the butterfly effect? The butterfly effect is when a butterfly flaps its wings, there's a certain small probability that the waves created by the butterfly will be magnified as it progresses. It may be enough to reach the tipping point that sets off a storm, okay? The point I'm raising is no computer is powerful enough to do that computation of a butterfly's wings that could set off a storm. Is it possible? Yes. Is it computable? Probably not. So in other words, chances are we do not live in a computer simulation. Sorry about that.